problem about permutations. So I'll first explain it to you guys. Suppose there are n number of books on a shelf, and you have to arrange those n number of books such that no two particular books are ever together. So we don't want these two books to ever be together. So what's the number of ways we can arrange them? Let's go. N books. Consider the two books to be one book. Therefore, total books in this case will be equal to n minus 1. Now, how many ways can you arrange this many numbers of books? N minus 1 factorial, or p n minus 1. So now, we can also arrange. So like, say if we have the books, like book 1, book 2, book 3, and the two books which we consider as 1, 4. Label them as X and Y. So when we have considered this one arrangement, we can arrange like that. We can have the same arrangement 1, 2, 3, 4, but 1, 2, 3, 4, but Y and X swap their positions. So basically what we do is n minus 1 factorial times 2. Yeah? Easy. Now, what I can tell you is we can have this many ways of arranging those books. So then initially when we had all these books separated and when we had n books, we'd have the number of ways of arranging this would be n factorial. Now to find out the number of ways of arranging these books such that they are never together would be just taking the total number of permutations, n factorial minus n minus 1 factorial times 2. So guys, I guess this is simple. And actually, to make it more simple, what I can do would be another thing what I could do would be you got this down here. N factorial. Arrange it as n minus 1 factorial minus n minus 1 factorial times 2. N minus 1 factorial minus 1 factorial. Common. Basically what you can do would be take n minus 1 factorial as common and basically multiply this by 1 minus actually what you could do would be put n inside because yeah, so n minus 1 times n would give you this minus n minus 1 times 2 would give you this. Basically you land up with n minus 1 factorial times n minus 2. Easy. This many ways of arranging the books when two particular books can't be together. Thank you. I think I'll give you another sum also. Okay. Let 6 boys and 4 girls stand in a line such that the girls never stand together. So 6 boys, 4 girls. Straight line, and no girls should be standing together. How can we arrange this? So for this one, you have to represent a diagram in the form of a diagram so that, well, I think it's easier in the form of a diagram. So B denotes boys, so 6 boys, right? 3, 3, 3, 1, 2, 3, 1, 2, 3, the straight line. And then x, 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 representing the place for the girls. They can be placed in x because they won't be next to the boys. So basically, you got 1, 2, 3, 4, 5, 6, 7 places for them. Now basically, and you've got 4 girls. So now, how many ways can you put these girls on the seats? So basically, you've got 7 seats distributed to 4 girls, or like make 4 boxes and then arrange them like that. So that's the number of ways you can arrange the girls over here. Times, the boys can also change their spots. 6 boys, so 6 factorial. So this is how you solve the sum. It sounds complicated, but it's really easy. Should we solve another one? So this question, I'll just write it down for you guys. How many ways can the word garden be arranged such that the vowels are in alphabetical order? And let's see, second part of the question. So as you can see, they're basically saying it's the word, number of ways of arranging them such that the vowels are in alphabetical order. So got 1, 2, 3, 4 consonants and 2 vowels. Now what you can observe is that consonant can be basically arranged in 6p by 4 ways, right? Yeah, because 4, 5, 6, because they can appear in any of this in any order. Whereas in each of these arrangements, 2 places will remain in which first 2 will be filled by A. Yeah, exactly, because A always has to be in the front, right? So basically what you have is, because it's a bit hard to explain, but times 1, which will give you 360. Let me explain it to you now. Because you have G, A, R, D, and consonants can appear in appear in any of the places. But the fact is, in each of these arrangements, 2 places will remain blank, in which the first place will be filled by A, and the place after this in only a way by E, as per the given condition, right? So vowels have to be in alphabetical order, so that's why we multiply it by 1. So required number of ways will obviously be 6p sub 4 times 1, which is equal to 360. It sounds a bit tricky, but it's really easy.